So we have to find inverse of a 3 by 3 matrix using the formula A inverse equals to determinant of A times adjoint of A. So in order to find inverse of a matrix, a 3 by 3 matrix, determinant should not be equals to 0. So the method to find determinant is that we select any row and expand it using row 1 in this example. So I'll leave the first row and first column. So at 2 by 2 determinant is left 4, 6, 9, 8, 9. Then we uh, leave the first row and second column. So we have 4, 6, 7, 9 and multiply by -2. We alternatively write plus and minus signs. So the next sum is positive. So we write 3 times of the determinant. So we leave the first row and the third column. So it's 4, 4, 7, 8 inside. And we expand the 2 by 2 determinant and get determinant equals to 12. Now we have to work out uh, 9 elements of the adjoint of A matrix. So each element should be like, we'll start with the A11. So it has the formula of -1 to the power 1 plus 1, and we have to find the determinant first, leaving first row first column again. So this is again this 4, 6, 8, 9. If we expand it, that's 1 times 36 and 48 minus 48, which is equals to -12. So we need the second element. This is going to be -1 to the power 1 plus 2. So it will be first row second column. First row second column. So the determinant is 4, 6, 7, 9. So this is equals to -1 times 36 minus, or 7 times 6 is 42, which is -6. So this becomes +6 here. Now the third element, -1 to the power of 1 plus 3. So first row third column. So the determinant is 4, 4, 7, 8. So that's +1 times 32 minus 28, which is 4. Now second row first column, -1 to the power 2 plus 1. So we have to go to second row first column. Second row first column. So the determinant left is 2, 3, 8, 9. So this is -1, 18 minus 24, which is -6 times -1 is +6. 2, 2, -1 to the power 2 plus 2. That's second row second column. So the leftover determinant is 1, 3, 7, 9. So it's going to be +1 times 9 minus 21, which is -12, and then a 2, 3, second row third column, 2 plus 3. second row, third column. So it's 1, 2, 7, 8. This is going to be minus 1 times 8 minus 14, which is minus 6, becomes plus 6. Minus 1 to the power 3 plus 3. That means, sorry, this is 3 plus 1 here. Third row, first column. 3, 1, third row, first column. So 2, 3, 4, 6. So this is 1 times 12 minus 12. This is 0. And then a 3, 2 minus 1 to the power 3 plus 2. So third row, second column. Third row, second column. So it's 1, 3, 4, 6. So this is minus 1 times 6 minus 12. So it's minus 6 times minus 1 is plus 6 again. And the last one is A33. So minus 1 to the power 3 plus 3, which is the third row, third column. So 1, 2, 4, 4. 1, 2, 4, and 4. So this is plus 1 times 4 minus 8. So this is going to be minus 4 here. Alright. Now these are all the elements of the adjoint of A. So adjoint of A is found using this formula. Like this is A11 here, A12, A13, A21, A22, A23. These are the positions of the elements. A31, A32, A33. And we take its transpose. Now what does transpose means? Let me plug in these values first. So the A11 is minus 12, A12 is 6, A13 is 4, A21 is 6, A22 is minus 12, A23 is 6 again, A31 is 0, A32 is 6, A33 is minus 4, and it's transpose. Now the transpose means all the rows will become column. So this will become minus 12, 6, 0. This was your first column, but it becomes the first row. Similarly, second column becomes second row. So 6 minus 12, 6. And the third column becomes the third row. This is what transpose means. This is adjoint of A. Now, if you want the inverse of the matrix, it should be 1 over determinant of A, which was 12, times this. Now, if you want to confirm your answer for the inverse of the matrix, you should multiply matrix A with its inverse so that you get identity matrix. So I leave it for you. If you multiply this, so 1 over 12 is a scalar quantity. So 6 minus 12, 6 here, and 4, 6 minus 4. If you multiply this with the matrix A, which is 1, 2, 3, 4, 4, and 6, 7, 8, and 9, your answer must be identity matrix of order 3 by 3, which is 1, 0, 0, 0, 1, 0, and 0, 0, 1. So I leave this multiplication for you. Please check the answer.